Right, so let's go ahead and continue here. So far, you have this part of the wave function, right? Which is cool and all, but you notice most waves actually move around. I mean, this is a very still wave. It has, crest and troughs, it has a wavelength, and it has a certain amplitude, all of which we can adjust. But if we want to go ahead and describe a wave that's moving, like we do see in real life, like a sound wave that is actually moving past your ear right now, we're going to actually take into consideration the factor of time. Time is actually going to be very important. So what I'm going to do is I'm actually going to add something here, or subtract something, and this is only just because we need something to move forward. So I'm going to go ahead and do this. It's going to be the same format of this. Basically, I'm going to take into account a point in space. Okay, and we're going to add t. You notice t doesn't really do much to the equation. In fact, well, it does actually help it move back and forth, but as we've said before, if you really want this to work, you're going to have to take in consideration the factors that we know about the wave. We actually need to put in perspective the period of the wave. So here we go. You see right there, I'm going to set that to 0 here. Right here. Let's see, t equals to 0. There we go. You notice it's right there, right? But let's say that this wave is moving past you at like 2 seconds. Like it passes one wavelength every 2 seconds, or a period of that. Okay, so we're going to go ahead. If I go ahead and take it up to 2 seconds and let it play, right? You notice it actually doesn't really seem to be moving that way. So we need to actually take into account the factor of time. So I'm going to do the exact same thing we did for the other side. Just repeat, 2 pi. We're going to go ahead and divide this entire thing. And then after, we're going to go ahead and remember, that's only for the sake of getting sine to work correctly. And then after, we're going to go ahead and put in consideration our period, or t, capital T. And notice this will allow us to find a certain point in space, right? So let's say I wanted to figure out where the wave was at like 1 second, right? Well, then after comparing this with t, you notice I can go ahead and estimate as things move on. So here you're actually going to notice that one wavelength is going to pass you every 1 second if you go ahead and let this play. So I'm going to go ahead and play this, and you're going to actually see that wave move. Okay, maybe let's go ahead and try a longer period, something that takes long. So let's say every 5 seconds, one wavelength is going to pass by you. So we're going to go ahead, I'm going to set it back down to 0 here. And we're going to see 5 seconds that there's going to be a new wavelength here. So let's see. Oh, I went too far. Okay, let me go ahead. Maybe I should just do the slider. Okay. So that's at 0, right? So we're going to take it. And notice right here at 2.5, we're halfway through the wave. Okay, so this kind of represents that we're going to make it. And boom, you can see right there at 5 seconds, we have one wavelength that passed by us. And this is actually going to continue as compared to just having t by itself, where we really didn't have this measure of control. So if I go ahead and eliminate everything we put in and just put in t, it's not going to work as well. Wait, sorry. Okay, so notice I'm going to go ahead and have it do the same thing. So we wanted one wavelength to pass us every 5 seconds, right? So I'm going to, oh, okay. I see what's going on. Here we go. So we're going to start at 0, right? So we wanted a period of 5, right? So we're going to go ahead. Okay, so here we go. We're going to go ahead and see if it takes 5 seconds for a wavelength to pass us. And you can see we're at 3. You see this is already 5 seconds here, and it's taken us longer. So we know that that doesn't work. So we actually do need the 2 pi. You could argue, yeah, we could just divide by t, but you notice that's not going to actually help us much. So we are actually going to still need the 2 pi. So remember, the 2 pi is just to get the sign set correctly, and then after everything else is just to create a fraction. So basically, once we hit the period or some multiple of the period, that will allow us to go ahead and actually complete the fraction, making that a whole number and continue. But you notice if I increase time here, say I start at 0, right? And if I go to 5 seconds, you notice it takes forever, right? Because we don't have the 2 pi either. So you do need the 2 pi here. And that's how you do it. And that's how you're going to go ahead and get everything set. So you notice here we now have a moving wave, and I'm going to go ahead and just let this play out. And this kind of allows you to just see the timing of the wave moving past you. Now, do note, changing your period does not actually affect the shape of the wave. It only affects how long it takes for us to move through it. So notice, as we get to higher periods, we're going to see more wavelengths move through the entire thing. So just to emphasize, this part controls, the shape of the wave. So that will be the amplitude, the wavelength here. This part will control how fast it's moving towards you. And this is kind of the idea that we discussed with the entirety of the wave speed equation, right? You have one part that dictates, how long that wave is, and then after another part that dictates the timing of that wave. So this kind of actually really helps in showing the separation. Anyway, so what you're going to do next with this is actually create a wave poster. So you're going to actually create, well, imagine that this is a product or a magical equation that you're going to sell someone. Sell me this. Try to go ahead and tell me what makes this equation awesome. If you want to go ahead and play around with it in Desmos and tell me, how it works and, what every part does and why this is actually one of the better equations to describe a wave, go ahead and do that. That's what I want you to do. There's a rubric pasted on the assignment that should help you. Go ahead and do that. I'll go ahead and we'll see you on the other side of this. Okay. Hopefully you'll go ahead and enjoy this assignment. I'll see you next time.